All right, ladies and gentlemen, good evening. It's Algebra 1 time. Okay. Sorry, just trying to make sure I get this all nice in a good place for us to be able to utilize it tonight. All right, so we are working with multiplying polynomials tonight. Before we get started, before we even look at this, I wanted to remind you guys about the rules of exponents, okay? The rules of exponents are very important when we were working with multiplying polynomials, okay? In this case here, all I want you to pay attention to is the multiplication version right now. So when we're multiplying exponents, okay, so multiplying. When we're multiplying exponents like, say, x to the a power times x to the b power, okay? These are multiplying, okay? We have the exact same base, so that looks good. We just have two different values of exponents, okay? According to the rules of exponents, when you are multiplying, okay, you keep the same base, but you add the exponents, okay? So a plus b. So x to the a plus x to the b equals x a plus b. For an example, if we have x cubed times x to the fifth, we keep the base of x, and we add the two exponents of 3 and 5, like so. 3 plus 5 equals x to the 8th power. That's the rule of exponents when we are working with in this term of multiplying polynomials, okay? We'll get to it again when we get to raising exponents to exponents and when we get to dividing polynomials. All right, I'll show you how that works as well. But for right now, the rule of exponents, when we're talking about multiplying, keep the base, just add the exponents, okay? All right, so example number 1, Gisela computed 342 times 23 as follows, okay? Now, this goes back to elementary school. This is the way that they do multiplication, the crisscross method, okay? There are 3 different ways you can do this. We all know that you can do 342 times 23 this way, all right? You get 3 times 2 is 6, 3 times 4 is 12, carry the 1, 3 times 3 is 9, plus 1 is 10. We add a 0 in the 1's place because we're moving to the 10's place. 2 times 2 is 4, 2 times 4 is 8, 2 times 3 is 6. You add, you get 6, 6, 8, and 7. Okay, so 7,866. This is the crisscross method, okay? It's the table method. They take 342 and divide it into 3 hundreds, 40 tens, or excuse me, 3 100s, 4 tens, and 2 ones. Then they take 23 and they put it on the side, 2 tens, 3 ones. 20 times 2 is 40, 20 times 40 is 800, 20 times 300 is 600, okay? Or sorry, 20 times 30 is 6,000. Look, 6,840, same thing, okay? Then they move to the 3's. 3 times 2 is 6, 3 times 40 is 120, 3 times 3 is 900, okay? And then they add going across, okay, because what they do is they keep the 6's. Since the 6 is the only one, they put it there. 40 plus 120 gives you 160. 800 plus 900 gives you 1,700, okay? And then 6,000 is by itself because it's the only thousands. So thousands, hundreds, tens, ones. And then they add it together. All right, 6,000, 1,700, so that's 7,700 plus 160 is 7,860 plus 6 is 7,860. Okay, we just explained what she was doing, and we told you her final answer is 7,866. That is how she did that. That is what you call the grid method or the table method, however you want to look at it. 7,866. Okay, now they want us to use the diagram method, okay, or the geometric diagram to compute the following products. Okay, so it's the same concept. You got 3x squared, 4x, and 2, okay, times 2x and 3. Okay, So now we do the exact same thing that we did up there, but we're going to do it here. So 2x times 2 is going to be 4x. 2 times 4 is 8. X times x is x squared. 2 times 3 is 6. X squared times x is x cubed. How do you do that, Mr. Hale? Well, think about it. This is x squared times x. We don't see a value here on this x, do we? But we understand that there's a 1 there. So this is x2 plus 1, which is x cubed. Okay? Then we continue on. 3 times 2 is 6. 3 times 4 is 12. Bring down the x. 3 times 3 is 9. No x's here, and an x squared here, so we bring that down. So the same thing applies. The 6x cubed is by itself, so we write that down. The 8x squared and the 9x squared are like terms. There's the x squared, there's the x squared. So 9 plus 8 is 17 with the x squareds. 4x plus 12x gives us a positive 16x. Okay. Oh, wait a minute. We have this. No, never mind. I'm looking at the wrong thing. My bad. All right. And then we got this lonely little 6 right here, so plus 6. Okay. That's the geometric diagram way of doing this. Okay. I can show you the other way. It'll be a fun, long way, but for right now, this is a good way to introduce you into multiplying polynomials. This will get you a little bit more comfortable in doing it, okay? So let's look at C. All right, so we got the same situation, but this time we are looking at, okay, these are what you call trinomials, okay? We will go over the terms and all that again down the road, okay? For right now, I just want you to get used to the fact that, okay, anything with 3 terms is a trinomial. Anything with 2 terms is what we call a binomial, okay? All of these are known as polynomials, okay? More than one term, okay? Just like polytheistic, more than one God, all right? So 2x squared plus 10x plus 1 times x squared plus x plus 1. So we do the same thing again. We set up each individual term as its own set, so 2x squared, 10x, and 1. On the side, we do it again, x squared, x, and 1. All right, and then we're going to try to make this look a little bit better than I did the first time. Okay. See, a little bit better. All right, so same principle that we got to do, okay? Well, I got to make that look a little, there we go. Now we go. So x squared times 1 is just x squared. X times 1 is just x. 1 times 1 is just 1. Okay? You'll see how this all can work out any way you want to. X squared times 10x. So 10 times 1 is 10. X times x squared is going to be x cubed. Same concept we had up here. It's not changed. X squared times 2x squared. Well, 2 times 1 is 2. X squared times x squared is x to the 4th. 2 plus 2, 4. All right. X times 10x. So, well, 10 times 1 is 10. X times x, x squared. 1 times 10x, 10x. Okay. X times 2x squared. Well, 2 times 1 is 2. X squared times x, x cubed. All right. 1 times 2x squared is 2x squared. All right. We only have one term with an x to the 4th, so that's going to be the first thing we lead off with. 2x to the 4th plus, now we've got a 2x cubed and a 10x cubed. We're adding them, so 10 plus 2 is going to be 12, followed by the variable of x cubed. Then we're going to do the next column, the next diagonal column. We got the x squareds next. So 2 plus 10 is 12. There is an understood 1 right here. So 2 plus 10 is 12. 12 plus 1, that's 13. And we're working with x squareds. Okay? 10x plus 1x. That's our next column. So 10 plus 1 is 11. So plus 11x. And then we got just this lonely little 1 down here at the bottom, plus 1. Now, you're asking, Mr. Hale, why did you start off with the x to the 4th instead of, say, the x to the squared? Okay, when you're working with trinomials and binomials and polynomials, you'll notice that all the variables are either in ascending, or sorry, not variables, the exponents are always going to be in ascending or descending order. Okay, in this case, they're all in descending. 2, 1, 0. 2, 1, 0. If you have a question how I came up with 0, ask me tomorrow. I'll show you how that all works. Okay, so descending order is the most common thing. However, you can see ascending. So do not think ascending order is just automatically knocked out because you don't see it. All right. So that's how we do that. Do those first few problems. Okay. I want you to work on letter D for homework tonight. So this is your homework tonight. Okay. I want you to do this in your book if you have your book. Okay. All right. So exercise 2 gets a little bit interesting. Okay. This is a distributed property. All right. So they want us to take each of these terms and they want us to distribute into the polynomials. Okay. Now, I'm going to show you something that I want you to see this is a lot easier to do. Okay. I want you to remember these as individual terms. Okay. Each one of these is an individual term. All right. Now, if we use the distributive property, we know that each term is going to be used to multiply to this trinomial. So I can rewrite this as 3x squared times x to the fourth minus 2x plus 1 plus x times x to the fourth minus 2x plus 1 minus 1 times x to the fourth minus 2x plus 1. Mr. Hale, what did you do? Okay, all I did, okay, is if I took this and I said, okay, let's imagine that this right here, this whole thing right here, was a variable x, okay? Well, according to the distributive property, each one of these terms would be multiplied by x. 3x squared times x plus x times x minus 1 times x, correct? So what I did is I imagined that instead of an x being there, I had this term right here. So everywhere there was an x, I substituted what should have been there. So I went outside the box a little bit to come up with my answer. All right. Now, if this throws you off, just remember you could just take the 3x squared and multiply it by each term on the inside and then get your answer. Okay. Take the x and do the same thing, but that's exactly what I'm doing here. 3 times 1 is 3. X squared times x to the fourth is x to the sixth because 2 plus 4 is 6. 3 times a negative 2 is a negative 6. X squared times x is x cubed. 3x squared times a positive 1 is going to be a positive 3x squared. X times x to the fourth, that's going to be a positive x to the fifth. 1 plus 4, 5. Positive x times a negative 2x. Well, positive 1 times a negative 2 is going to be a negative 2. X to the first times x to the first is going to be x to the second. X to the first times a positive 1 is going to be just x, so plus x. A negative 1 times x to the fourth, that's a negative x to the fourth. A negative 1 times a negative 2x, that's going to be a positive 2x. A negative times a negative gives us a positive. Negative 1 times a positive 1 will be a negative 1. Okay? Now comes the fun part. You got to identify all your like terms. So I find the term with the highest exponential value. In this case, it's 6. Do I see anywhere else that there is an x to the 6th power? I don't. So 3x to the 6th is what's written next. The next power is x to the 5th. Do I see anywhere else that there is an x to the 5th? I don't. So plus x to the 5th. Okay. The next would be x to the 4th. Do I see an x to the 4th anywhere? Yes, I do, right here. So minus, see, I wrote plus. I didn't find it. So there is a minus there, so that is minus x to the 4th. Okay. X to the cubed is right here. Okay. So I'm going to make sure I didn't mess up anywhere. Okay. So Let's see, can there's any way for me to get another x to the cubed? There is not. So I know that I'm right so far. So minus 6x cubed. Next, I'm looking for x squareds. Here's 1 and here's 1. 3 minus 2 is 1, so I'm left with just a positive x squared. Next, I'm looking for x's. I got a positive x and I got a positive 2x. I understand that there's a 1 right here. So 1x plus 2x gives me 3x. And last but not least is a minus 1. There's my answer. Using the distributive property, I saved myself a lot of steps. But at the same time, I could have made an error. Okay? This method does provide an opportunity for mistakes to be made, especially if you don't understand what you're doing in terms of the distributive property. Okay, I'm 36 years old. I've been working on algebra since I was 13. Okay, that's 23 years of practicing Algebra 1. That's 23 years that I've learned how to make shortcuts that work. Okay? I'm not expecting you to get every single one of these the first time you do it. But the more you practice, the better you'll become. Just remember, exponents always are going to be written in descending order. Well, 99% of the time, okay? All right. Exercise 3, the expression 10x squared plus 6x cubed is the result of applying the distributive property to the expression 2x squared times 5 plus 3x. It is also the result of applying the distributive property to 2 times 5x squared plus 3x cubed, or to x times 10x plus 6x squared, for example, or even to 1 times 10x squared plus 6x cubed. For a through j below, write down an expression such that if you apply the distributive property to your expression, it would give the results provided. Give interesting answers. Okay. All right, so the first thing I notice right now, they're asking you basically to factor something out. We haven't got to factoring, but you can practice that right now. See, for example, I'm sitting here thinking to myself, well, I know 6 and 14 are both have factors of 2, so I know 2 is a possible factor for me to work with. Okay. I got an a there, so I could say an a is a possible factor I can work with. So my distributive property answer could be 2a. So what number did I have to multiply by 2a to get 6a? 3. Plus, what number did I have to multiply 2 to get 14? 7. And what letter did I have to multiply a by to get a squared? A. That's one of the problems I could have come up with. I could also say that I multiplied it by a. A times 6 gives me 6a plus 14 times a. That's another one I could have done. I just gave you a. Okay? It says there's 2j. So that means there's B, C, D, E, F, G, H, I, J. There's 9 more problems. That's your homework. I want you to finish those 9 problems. Come up with an example. Work with it. This is a great way for you to practice understanding how the distributive property works when it comes to multiplying polynomials. Okay? And I like these. Some of these are really good problems. Okay? All right, and that's where we're going to cut it out for the night. As a matter of fact, though, I'll give you a bonus, okay? So find a polynomial that when multiplied by 2x squared plus 3x plus 1 gives you the answer of 2x cubed plus x squared minus 2x minus 1. This is telling you a polynomial, okay? This is not just going to be a letter on the outside. This is not the distributive property. This is going to be a literal polynomial. You get this one right, okay? You get it right? No, I'll give you a free classwork grade. Automatically, I'll give you a free classwork grade if you get this problem right. Okay? So I'm going to keep my mouth shut from there. Be prepared for your answers tomorrow for the other stuff, because if you look, we have plenty to work on. Okay? There is plenty for us to do tomorrow. I need you prepared because we got a lot of work to do. I need to know that you can master this. All right? So with that being said, guys, I want you to have a good night. Get your notes taken care of, and we will talk first thing tomorrow morning. All right? Arrivederci. Ciao. Au revoir. Hasta luego. Buenas tardes, I believe. Or is it tardes? I think it's buenas tardes. So good night. La da da, la da 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 da, oh la da da da, la dee 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 dee, la da da da, la da da dee 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 dee.